was that plant we were talking about earlier?
I'm just messing with you. So they did tell me I could do whatever I needed to get make sure you got your work done. So.
Oh, that works. That works. What do you have? What did you say? Turn back. I hope you don't.
In that white box, file on that front table. You don't have to get them right now. Just if you want them back today. There's 3x3.
Oh my god, oh my god. Yes.
It's so cold.
Wait, where are you? 13. Wait, which one's and Gabby's? Gabby's twin. Bro, you're so lucky. I can't. Aw, he's nice like that. Oh my god. Oh, it's so. Oh, seriously? You guys are next to each other again. Oh, yeah. You know.
I can't see.
Wait, Catherine, I'm liking all of these glasses.
I'm
those.
23.
I like those so much.
Oh, where
You're
Sorry.
You're 24. Swim. I messed it up. I really like that. We made that this morning. Your hair looks so cute.
Thank you.
Oh, that's awesome. Not even close. Bye, break. It's okay.
We're just gonna get started on them.
He didn't even put my. Wait, did he just put it? He just put it. No.
Not great. Not great.
They didn't even put mine in. Like, what was that? What Oh my goodness.
Wait, this is the great one. I don't know. Bro, obviously that. No. No idea. No idea. Okay, but I'm right here. Hey, what happened to your
There. All right, take a seat, please. I need to see who's here, who's not here. Johnny, you're going to be kind of late if you got to make your way to your seat.
I'm working at the polls at 1, so I will need to leave like 10 minutes early. Is that okay?
Yeah, they'll need to change it to school business.
Miss Pinner changed it to school business after you sent her a picture of you being there. I can
That's
show
fine.
you. Okay.
I just have to mark you absent if you leave.
Yeah.
You need to make sure that she gets it.
No, yeah.
Because I can't change it.
Yeah.
Okay, Angel, you are now party.
I'm leaving it at home. Would you get that thing?
There was also Okay. It's time to get started, guys. Okay. Johnny. Stop. We're still in class. Okay, guys, listen up, please. All right, so obviously we've got new seats this morning. I will warn you, though, that some of these seats are not going to last because, like, Mia's not listening to me right now, so she won't know what's happening in a couple weeks. But if you like your seat, you need to protect it in that, I expect you guys to be ready to start at the bell, which I gave you a little bit of grace here because some people were finding their seat last minute, and to stay on task. So I like to pair you up with people you work well with, but not at the expense of being a distraction to others. So if you like your partner or you like your seat, the best way to hang on to that is to show me by doing a good job with it. And if you don't, then I will know not to put you next to each other next time. Okay, we've got a little bit of an adjustment here based on y'all are my third class to do this lesson, so I thought we would have plenty of time to finish up the number 40 notes. And when I say finish, your class didn't get started on those, so y'all are a touch behind. But you did pick up those handout. It's a 2-page handout. You picked those up after the test. We just didn't have time to start on it last time. So you need to find that in your binder, please. I did not have a book handout for you to pick up because we didn't have time to get to it in my other classes, so I'm guessing we won't have time to get to it here today either. So obviously we are moving into the 4th unit. And in the 4th unit, I don't know, everyone's different of course, but the 4th unit usually feels more intuitive to people than Unit 3. Allie, you have a late pass?
Yes.
And I should tell you that most, short of a couple things right before the end of the semester, and mean value theorem and extreme value theorem, even extreme value theorem, most of the rest of this semester is on something called function analysis, which basically means if we give you a function, you should be able to give a pretty good looking graph on what that looks like without a calculator. So you've done the same thing in Algebra 2, but in Algebra 2 you did it with quadratics. You learned how to find zeros, you learned how to find x-intercepts, y-intercepts, vertex, does it open up or open down? You piece all that together and you can figure out what a quadratic look like. You need something? You can figure out what that looks like without a calculator. We do the same thing, but we do it for pretty much any function, and that just starts today. So pretty much everything we do is about what would this look like, what does it mean about the behavior of the function. So to start that off, we have something called the first derivative test. And hold on, you can ignore this for a second. This is the stuff that my other class got to. They just finished the test a little bit faster. Ignore this real fast. Okay. And if you can't find your number 40, you need to go get an extra copy out of the basket over there. Okay, but using a quadratic as an example over here, there are some times that the slope is positive there are times where the slope is negative, and there's one instant where the slope is 0. Now, what does that have to do with calculus? Well, what instead of saying slope, we tend to say what? So when the first derivative is positive, your graph is going up. If the first derivative is negative, it's going down. And when the first derivative is 0, it is constant. Derivative means slope. If that has stuck in your head already, then I'm not really saying anything new there. If you want to know when your graph's going up, you're trying to figure out when the first derivative is positive. If you're trying to figure out where your graph is at rest, you're trying to figure out where the derivative is 0. You're trying to figure out where your graph is decreasing, you're trying to figure out where the first derivative is negative. So, I guess if you knew nothing else, if I gave you a function, you could take its derivative. So down here, here's a function. You could take its derivative and you could start plugging in points. If you plug in 1 into the first derivative and it gives you something positive, you know the graph's going up during that time. If you plug in 5 into the first derivative and it's something negative, you know it's going down during that time. The problem with that method alone is you would have to test every single value to know when it's going up and when it's going down. So, for efficiency, we have something called critical numbers or critical points. And critical because they are important. And critical points are the only place that a graph might change direction. So this is usually the first thing that we seek out, because if we know where the graph might change direction, then we can narrow it down to just testing a few separate points. So critical points occur when the first derivative is 0 or undefined. So 90% of the time we do it where it's 0, but you also need to reinforce where it's undefined because that shows up on a test also. But critical points, the reason they are so important, they're so critical, these are the only place the function may change directions. So, in just a second, we'll look at we will look at question or example 1 down here, which has you do a little bit of everything. But to be truthful with you, your next test and even your AP exam is going to ask a question or two just asking you to find critical point. So basically, you're going to find the first derivative and find where it's 0 or undefined. Sometimes it's going to ask you for increasing, decreasing segments. So we're getting to that. And then finally, the last leg of this is knowing where the function is increasing and decreasing is an application of the first derivative. The actual first derivative test, the purpose of this test is to find local or relative, same thing, extrema. And extrema is a vague term for what? The max and mins. So if you were asked to apply the first derivative test, you were actually trying to find all the relative maxes and relative mins. 100% the same thing you did in Algebra 2, but in Algebra 2, your teacher either gave you a calculator so you could just graph it and look for the maxes and the mins, or they gave you the graph and you just had to look at the graph. With the first derivative, we can quickly find that. So most all the questions will start off with critical points. Then we will go a little bit further to figure out where it's increasing, decreasing, and then sometimes we go even a little bit further in that, and we can use that to find relative maxes and relative mins. Okay, so to talk about this in calculus terms, there's a minimum at x equals c if the derivative, So to have a minimum, it's got to look like this. So the derivative goes from being negative, the slope goes from being negative to positive. But in calculus, we will say the derivative goes from negative to positive. And if it's a maximum, the derivatives, the slope's going from positive to negative, so that means the derivative's going from positive to negative. And when we have to justify these answers, this is the justification that they're looking for. Don't overcomplicate the justification. If it's a minimum, it's because it was going down and then it started going up. If it's a relative max, it was going up and then it's going down. But we would say that in calculus terms. Okay, so question 1, which is a little bit of everything. So you'll see why I'm doing this after a few examples, but at first you just kind of have to bear with me here. So the first thing I always want to do is find critical numbers. Critical numbers are the only place this graph might be changing direction. So critical numbers, you just have to memorize, is when the first derivative is 0 or undefined, which implies that sometimes you've got to take the derivative. So power rule, chain rule. Now, of course, some derivatives are going to be messier than others. Some have chain rule, some don't. Some are product rule, some aren't. Some are quotient rule. But there's not any new derivatives, taking derivatives you haven't seen. We're just getting better at it. Now, because this is a fraction, when does a fraction equal 0?
Top 0.
Okay, so it looks like x equals 0 is one critical number because it makes our first derivative 0. And then how would a fraction be undefined? Okay. So set the denominator equal to 0 and solve. You would get plus or minus 2. Now, again, at first, this is a lot for one question. But honestly, these are the only two things that make these questions harder. Sometimes the derivative is harder than others, and sometimes the solving is a little bit harder. But the rest of it follows a pattern where they all basically do the same thing. So all of these are, we've got 3 critical numbers or critical points. I say those kind of interchangeably. Critical numbers are technically numbers that make the first derivative 0 or undefined. Critical points are critical numbers that are points on the graph. So if the original function didn't exist at one of these, they couldn't be called points because they're not really points. Okay, so sometimes you get to quit there. Depends on the question. Sometimes you just find critical numbers and be done. I can promise you at least one of your questions on your next test, that's it. But sometimes we want to know instead, when is this graph increasing and decreasing, this function? So we're going to do this thing called a line chart. Now, a line chart does not count towards any justification, but you're going to see why it's nice. So I've got x equals 0 is a critical number. I've got x equals 2 is a critical number. And I've got x equals negative 2 is a critical number. Just listing them all on a number line. Those are the only 3 times it might change direction. It's not guaranteed to change direction. So if I want to know if the graph is increasing or decreasing here, I just want to know, is the first derivative positive or negative over here? Since there's no more critical numbers past 2, I know it's never going to change. I just need to plug something in that's bigger than 2, something easy like 3, into the first derivative. So if I actually don't even care about the number. I only care if the number is positive or negative. So if I plug in a 3, the numerator is positive, the denominator is positive, a positive divided by a positive is positive. And what do we know about a function if its derivative is positive? Right. Derivative means slope. If slope's positive, then the graph's going up. I don't have to worry about it changing directions after that because there's no more critical numbers over here. But since he might have changed directions at x equals 2, I need to test in here also. We actually have to test both sides of every critical number. So pick any number between 0 and 2. You know, don't pick 1/10. Don't make your life hard. Whatever it's doing in here is what it's doing in here. So I'm going to pick 1. Just sounds easy to me. Plug 1 in. I get positive over a negative, which is negative. And when your first derivative is negative, your slope is negative. And when your slope is negative, your graph is going down. So draw a little line that looks like it's going down. All right, we've got a test between -2 and 0, so I'll throw in -1. That would be a negative over a negative, which is positive. And it might be changing directions here, so I've got to test one more time. I'll throw -3 into the derivative. This would be a negative over a positive, which is negative. Now notice, again, the nice thing is you don't care what the number is. You only care if it's positive or negative. But every time it's positive, I know the graph is increasing. Every time the derivative is negative, I know it's decreasing. Now, to be fair, I don't know what it's increasing to or decreasing from or any of that kind of stuff, but I have a general shape of the graph. He goes down till x equals -2, then he goes up till 0, then he goes down till 2, and then he goes up forever. So, if I wanted to answer, and we don't really have questions like this today, so you don't have to write this down, but if I needed to tell you where it's increasing, I've got a visual. It's -2 to 0 and 2 to infinity. It's kind of hard to miss when you have this in front of you. If I was asked where is it decreasing, well, it's decreasing from the far left till -2 and decreasing from 0 to 2. So sometimes you're just asked where is it increasing and decreasing, and this little line chart here shows you all the information you need. For us, this question is actually asking us to use the first derivative test to find relative extrema. Well, now that you can see the graph goes down, up, do you think there are any relative maxes? Okay, where do they occur? Right here. It was going up and then it came down. So we know there's a relative max at x equals 0. Any others? Okay, what about relative or local min? Good. It was going down, then up. It was going down, then up. So at x equals plus or minus 2 are relative mins. So sometimes it asks that, and then sometimes it will ask you to justify. We're just going to justify on most all of these today. But this was a relative max because the derivative was going from positive to negative, and these were relative mins because they were going down and then they went up. But we're just going to explain that with calculus, with the derivative. So again, the biggest connection you really have to make to survive this is to know that first derivative gives you slope. When the first derivative is positive, the slope is positive, and you know the graph's going up. When the first derivative is negative, the slope is negative, so the graph is going down. But sometimes we just find critical points. Sometimes we just figure out where it's increasing, decreasing. And then I guess the furthest questions that take the most work, even though it's all basically the same, is finding the relative extrema. But if you know where it's increasing, decreasing, then all that is just right there. Okay, so I'm going to say basically the same thing. All that's really changing here is the function. So if I want to find critical numbers, because I know those are the only place my graph might change direction, how do I find critical numbers?
Take the derivative.
You need the derivative, not the function. Now this is one of the parts that can be messier. This one is more on the bad side, I guess, because you're going to have to use quotient rule. Derivative of the top with the bottom left alone minus the derivative of the bottom times the top left alone all over the denominator squared. Now, if I need to know where this is 0 or undefined, I guess undefined's not too bad, but where it equals 0 is kind of a pain. I'm going to simplify this a little bit just for my own sanity. I've got negative 2x squared. Yeah.
Would be negative x squared. It's a quotient rule. Positive. You know what I'm saying? X squared would be negative.
Okay, so it's minus the numerator left alone times the derivative of the denominator. What's the derivative of the denominator?
-1. Oh, sorry.
So, yeah. No, that's fine. You guys still need to, if I ever do a product rule, quotient rule, chain rule step that you don't see or you think is wrong, you'll need to speak up. But otherwise, I don't dwell on that too much because you've at least seen that part before. You obviously will continue to get better the more you have to do it, but I'm not going to spend a long time on that. Now, if I distribute this, I've got negative 2x squared plus an x squared gives me a negative x squared. But I've also got a 2x times 4, which is 8x. So normally I only simplify for multiple choice questions to try to figure out which answer is the same. But for my sanity here, I need to know where this is 0 and undefined. And that was just going to be harder for me to do it over here. But a fraction equals 0 when the numerator equals 0. We could factor and get 0 and 8. So, is 0 and 8 the only critical numbers then? Okay, good. Also where it's undefined. So where the denominator equals 0, which would be at 4. So if the question only asks you to go seek out critical numbers, there's your 3 critical numbers. You can quit and be done. But the reason critical numbers are so important is because we could make this little line chart and say x equals 0, 4, and 8 are likely to be turning points. Those are the only 3 times it might be changing direction. So if I test around those, I can figure out the entire time the function's going up and down. So if I want to know what's going on here, what do I need to do?
Plug in just a number between there.
Okay, a number between what and what?
4 and 8.
Right, if you want to know what's happening between 4 and 8, throw in a number in between those into the derivative. You would plug it into the function if you wanted a point. If we want to know the slope, we need to plug it into the derivative. Okay, so again, this can be a little careful here. Plug in 5, we would get 40 minus 25, which is positive. What about the denominator? Is the denominator ever going to be negative? Good, because if you square something, it's always positive, right? So positive over a positive is positive. Positive derivative means positive slope. Positive slope means your graph's going up. Repeat. It's likely, I said not probably, but likely to change direction here. So I need to test what's going on after 8. So I'll plug in 9. 8 times 9 minus 9 squared is negative, divided by a positive, which is negative. If the derivative is negative, the slope is negative. If the slope is negative, your graph is decreasing. I need to figure out what's happening in here. So test something between 0 and 4. I will pick out 1. That would be negative over a positive, which is negative, decreasing, and it might be changing direction here. So I've got to test one more. I don't know, throw in negative 1. You get negative 8 minus 1 is negative over positive. Negative over positive is negative. Does that sound right?
Why is plugging positive 1 negative?
because this would be 8 minus 1, which would be 8. Well, wait, what's wrong with that? 8 minus 1 is 7. That's positive. And the denominator is always positive. So this is positive. Is that not what I had? Okay. So I'm trying to do the arithmetic real quick. Obviously, don't learn from my mistake here. That if you do it too fast, just because you don't have to know the exact number, if you do it too fast and you mess up whether it's positive or negative, it messes this up. Okay, now if the question wanted to know when is it increasing, well, I can see where it's increasing, from 0 to 4 and from 4 to 8. Done. If the question asks when is it decreasing, I can see when it's decreasing. It's decreasing from negative infinity to 0 and from 8 to infinity. Done. That's not the questions we're answering today, but that work is already done. So if the question is find the relative maxes and mins, or if the question is use the first derivative test to find the relative extrema, all the same thing. Now we've got kind of a visual here. Looks like we've got a relative min because it's bottoming out here. So relative min at x equals 0, because the derivative is going from negative to positive. Notice this, I didn't make up these questions or this set of notes, but notice critical numbers don't guarantee that it changes direction. If something goes up and then it's 0 for a moment and then it goes up, that's not a relative max or relative min. In fact, the common function that you should be familiar with that is x cubed. X cubed is 0 for 1 instant, but he's increasing before and he's increasing after. He doesn't have any relative extrema. That's basically what's happening right here. He's going up, he's constant for an instant, and then he goes up. This is nothing. It's got to be changing directions. So the other one is right here. That is the only relative max. It's occurring at x equals 8. And if I needed to justify my answer, I know that because the derivative was positive, it was going up, and then it switched to being negative, which made it go down. If you can practice and feel comfortable making this sign chart like this as we move along today, you can see how easy it is to extract your answers out of it. But got to be able to find the critical numbers, know what they do for us, know to test around the critical numbers into the derivative, know what it means for a positive versus a negative derivative, and then the rest kind of flows. Okay, so now we're moving on to the practice part. So those are pretty tough questions. That's really kind of what we're building up to give you some exposure. But on the next page, here's a question where they gave you the same information in a table instead of a line chart, and it wants you to try to figure out if there's any relative extrema, and if there are, justify your answers. So now I need you guys to start practicing before we talk about them together. So I'll give you a minute to try question 1, see what you come up with, or at the very least, at least see where you get stuck or figure out where your confusion is. And then we'll go from there. feel like that one shouldn't have taken too long. So, did you think there was any relative or local maxes?
Yes.
Okay, where at? X equals what?
-2.
Okay, and so now to me, I'm not used to thinking of it this way, so I would maybe take the 10 seconds of effort to see that something's happened at -2. Looks like it might be switching at 0 and it might be switching at 3. Positive derivative, negative derivative, negative derivative, positive derivative. For me, this is just easier to visualize, but you can do what you want. Relative max at -2, and then to justify that, I mean, honestly, if you know there's a max there, you've already put that thought into it. You just have to put pencil to paper and write it down. This is where the derivative is going from positive to negative. You don't need a paragraph to justify the answer. That's all that's going on. Okay, and then again, I think it's a lot easier to see if you go ahead and list it out like this, but I leave that up to you. There is a one local min at x equals 3, and that's because the derivative was negative and then switched to positive there. You guys okay with that? Okay. So questions 2 and 3 are the same type of question, and I want to give you just about 30-45 seconds to try question 2. I'm going to guess that most of you are going to fall into a common trap here, but I want you to have a chance to see if you do that without me giving you a hint. So start question 2 and see if you take the correct path. Okay, I know I did not give you much time. That's okay. I just wanted you to see if you took the bait on what to do here. Okay, did you say that there's relative mins here and here and a relative max there? Okay, you're treating this like an Algebra 2 problem. In Algebra 2, your teacher gave you the function or gave you a calculator to graph the function. So sure, if this is the function, these are relative mins and this is a relative max. We don't normally do that in calculus though. This isn't a graph of f of x, it's the graph of his derivative. So it's not that it's really that much harder, but you do have to approach the question differently. It's not as obvious as you may want it to be. So I guess my question would be, what are some times that the derivative is positive? Sorry? What'd you say? Okay, how do you know from 2 to infinity is positive?
It's above the x-axis.
Good, these are positive values. Positive 1, positive 2, positive 3, positive 4. These are also positive. These are when the first derivative is negative, because these are negative values. So, is there any time that the derivative switches from being positive to negative? Okay, and when it switches from being positive derivative to a negative derivative, that is a relative max. It was going up and then it was going down. It's a relative max. Okay, so does that mean x equals positive 2 is also a relative max? Very good. It's relative min because it was going from a negative derivative to a positive derivative. That is a relative or local minimum. So it's just a different way to think of things. Instead of you just being told like the last question in the chart, here's where it's positive, here's where it's negative. They're telling you the same thing. Here's the first derivative. You can see where it's positive, you can see where it's negative. It's just that it's in graph format. But by far the most important thing here is you need to pay attention to the directions. If this was f of x, it would be a 2-second question. It's 99% of the time it's going to be f prime though. It's going to be his derivative. Okay, so now that you are aware of that, go ahead and do question 3. And I will give you more time than I gave you for question 2. Okay, let's check question 3. So I think it's a bad idea to do this. I know some students start to say, oh, okay, well, I'll just memorize above the x-axis is one thing and below the x-axis is another thing. Sure, that technically works for today, but that doesn't necessarily translate that well. But to me, there is 1, 2, 3, 4 critical numbers that I can see. There's 4 times that the first derivative is 0, but not all critical numbers are relative extrema. It's actually got to cross the x-axis. It's got to switch from being positive to negative or negative to positive. So you should have said x equals negative 2.5 is a relative max because it was derivative was positive and then it switched to negative. Graph was going up and then it started going down, relative max. And at x equals 1, there is a relative min because the graph was going down, negative derivative, and then it switched to going up, positive derivative. Good with that? So it's not as easy as it just being f of x, but it's not that hard either. Just be careful that you're working the question you think you're working. Okay, anything you want to ask there? Yeah.
So, like, the fact that it's crossing the axis means that it's, like, changing from being a negative or a positive derivative, but, like, what does it mean when, like, the slope of the derivative looks like it's going up and down? Like, does that make sense?
So like this is negative, has a value of -2, and up here this has a value of -1. So it's just getting more negative. It's like steepness of the curve is what you're measuring. So this would be like it's going up at a pretty consistent rate, and then this is going down at a pretty consistent rate, but then this curvature, it's like it's getting bigger. It's still negative, but it's growing quicker and then approaches 0. So it kind of goes to where it's 0, but then it goes back to being negative again. So we eventually pull all this together. Today we're just finding relative maxes and mins and increasing segments, decreasing segments, but we do some other graph stuff that all of it comes together, and then we can get pretty accurate graphs of the real thing. Okay, so to inch out, and still the same stuff, but they're moving us towards the, I guess what we saw in the examples on the front page. So this question wants us to find all the relative maxes and mins again and justify our answers like we've been doing, but instead of a table, instead of a graph, and they are giving us the derivative. Now the nice thing about that is if they're giving us the first derivative, it means we don't have to find it. But I would want to find critical numbers or critical points. So is this ever going to be undefined? How do you know it's not going to be undefined? Okay. Is this ever undefined? It has a denominator. Right. Anytime you have a variable in the denominator, it could be undefined. Okay, so this guy's never undefined, but it's also when the derivative equals 0, and it's already factored, so we could set each factor equal to 0 and solve. Now e to the x never equals 0. You can either solve that algebraically, or if you remember what exponential growth looks like, he never equals 0. But there's only one critical number, so there's only one time that it might be changing directions. So I'd like to know what's happening to the right of this. So I'll try 0. I would get 4 times 1, which is positive, increasing. I might try -5. Which would be negative times a positive, which is negative, which means the function is decreasing. Now if you want me to tell you where it's increasing, it's -4 to infinity. If you want to know where it's decreasing, it's -infinity to -4. Or if you want to know where the relative extrema are, all of that's pretty much the same amount of work at this point. X equals -4 is a relative min, because G prime was negative and switches to positive there. There's our answer. Very consistent. You should start to notice a lot of repetition here. I can't necessarily make the derivative easier for you. I can't necessarily make finding the critical numbers easier, the algebra, but the calculus is mostly just seeing how all this falls together and connects together. Okay. I would like you to try question 5. Notice they're giving you the derivative, so you don't even have to find the derivative yet. And a few more questions, they will have us also find the derivative. But right now they're still trying to inch us towards where we need to be. I may not have given you enough time, but that's okay. You're still going to have a few more practice. So the first thing you should realize is if you want to know when it's increasing, decreasing, the most efficient way to do that is figure out where it might be changing directions, which is critical numbers. So you have to figure out where the first derivative is 0 or undefined. This one's pretty easy on that step. Obviously, sometimes it's a little bit harder. Looks like -1 and -4 were your critical numbers. And again, some questions, that's all they ask for, even on your AP exam. You just have to know how to go about finding it and be able to do it. Okay, we can extend that and figure out where it's increasing, decreasing by making a sign chart. So -4 is a critical number, -1 is a critical number, the only two places it might change direction. So I want to see what's happening over here. It's positive, so it must be increasing during those times. I need to figure out what's going on here. Maybe I'll try -2. By the way, sometimes, did you guys all plug in the values up into this? That's fine if you can do that arithmetic in your head, but a lot of times it's easier if you plug it into the factored form. -2 plus 4 is positive, -2 plus 1 is negative. A positive times a negative is negative. To me, that's easier than thinking about -2 squared plus 5 times -2 plus 4, but whatever's easier for you. Okay, and I need to figure out what's going on over here. So plugging in -5 would be negative times negative, which is positive, which means the graph is increasing. Now I can tell you where it's increasing or decreasing if you needed to know it. And for this question, the relative max and mins, I can see the relative max here and I can see the relative min there. So matter of just stating it, relative max at x equals -4, because G prime switched from positive to negative, and there's a relative min at x equals -1 because G prime went from negative to positive. The answer is usually pretty obvious if you can do the sign chart. Again, the sign chart does not count as justification on FRQ, but it's such a good way to visualize what you're doing that I think it's a big mistake not to do that. Okay, so I've got 2 more things I want to say, and then I can give you some time to work on this. Again, I'm not asking you guys to do any of the book assignment that was on the agenda, but I will ask that you finish this up. Okay, the next thing is you don't need to get up and get a calculator right now because I'm going to put this one up here for us. But here is f prime. They give us this, and they say use a calculator to find all of the relative maxes and mins. So if I had a calculator, I could go and graph this function. Now, because it's got a trig function, you better make sure you're in radians. Yesterday in my 3rd period class, I did this whole question in degrees and then had to start over and redo it. You can graph it. Here's a graph of the derivative. You're going to be tempted to say, here's the max and here's a relative min, but why is this not the relative max and this the relative min? It's the derivative graph. So it's really the same question we did up above. I think question 2 and 3. It's just that I had to graph it instead of the graph being done for me. And you've got to be able to do this within 3 decimals of accuracy. So right here, to me, this looks like a relative minimum because the graph's going down, negative derivative, and then going up, positive derivative. But it's not at x equals 1. It's just close to x equals 1. So how do I get more accurate there? Very good. The thing that we practiced on that calculator circuit the other day. I told you that these are just some of the skills that just show up sometimes. So calculate 0, left bound, right bound, skip guess. There is a relative min at 1.018. 1.018. Now they say you don't even need to justify, but of course I could. I knew that was a relative min because the derivative switched from negative to positive. It was going down, then it went up, relative min. Okay, what about this point? The one near -1. Is that a relative max or a relative min? Max. The graph's going up, positive derivative, and then going down, negative derivative. So it's just a matter of finding that value within 3 decimal places. So just make sure you know how to get your calculator to do that. -1.250 is a local max. And there's one more. There's one more time where the derivative sign changed right here. So ask it to find that 0. And it's at about -1.922. Okay, but is that a relative max or a relative min? Min. It was going down and then it's going up. Negative derivative to positive derivative. Negative slope to positive slope. A negative slope to a positive slope creates a relative or local min. Relative and local mean the same thing, so I'm trying to use both terms so that doesn't mess you up. But again, if you can do these two, the calculator questions are the exact same thing, except you got to type it in and have it graph it, and if the x-intercepts are some weird value, you need to ask it to trace to get it within 3 decimal places. Okay, so in just a few minutes, you will need to do 7 and 8 with the calculator. I think you can figure those out, but I'll go around in the room and help you out. So in just a few minutes, you can get up and get one of my calculators if you need it. I normally put that under bell work if I know you need one, but today we had the seating chart. So the only other hint I want to give you, moving on to question 9, is question 9, they inch you all the way out to the far extreme. Same old questions, first derivative test, find the extremas, justify your answers, but unlike the last few questions, they gave you the derivative to make it a little bit easier. The only difference starting at question 9 is you have to find the derivative yourself. So sometimes that's power rule, number 10 sometimes it's product rule, number 11 sometimes it's quotient rule. So the derivative can vary in difficulty, but it's all things that you guys have seen. So, and then it's like, as soon as you take the derivative, it's no different than what we did in questions 4 and 5. Okay, so I need y'all to start with that, please. I'd like you to aim to try to finish, of course, because if you do finish, then I don't have any homework for you. But I do need you to try all of this between now and Thursday, please. Looks like we've got about 35 minutes of class. So I'll give you a minute or two head start, and then I'll come around the room and try to help out with anything that's not working well. And of course, you're welcome to quietly work with your neighbor if you can do that quiet enough that it doesn't disrupt anybody else. You guys can compare and contrast your work and help each other. Yeah, and if you need one of my calculators, come help yourself. Just put it back at the end of class, please. Y'all understand the daily mean now? Excuse me?
That's pretty good. That's not bad. I like that one.
Wait, 41.
Did you guys do that last class? Or, 'cause I looked on the slide, just for the test, and I saw that. I could be wrong.
What do I have written down right now?
I'm wrong. Just finished 41. Got started at some point.
Well, start over. What is your question?
It says finish 41.
That's correct. That
Yes.
was the plan.
Okay.
The plan changed.
Now it's start 41.
You don't have to do anything on 41.
Okay. It's not the next class.
Why do you need to be locked in at the start of class so you know what's going on? I thought we could finish this up faster. And then y'all could get most, if not all, the test, because there's not many questions, and you can finish it up for homework.
Okay.
Based on my first two classes, we didn't even get to this in class.
Gotcha.
So, I'm just trying, I mean, obviously, it's better if you all did that early, but you have to at least finish them before. The agenda is just our tentative plan. It's not always what we get to. So this is what you need to finish and feel good about by next class. So, you got 30 minutes right now to.
We have to find the next x-axis and then just across from the x-axis.
I do have more calculators if somebody else needs one.
I know what you're talking about, the equation solver. It's just this, you hit the graph.
That might be a problem. Sure.
But either x. Does it ever cross over? 5 would turn to 0. Does it ever cross over? Oh wait, yes it does. So why is it negative? Yeah, I told you. You can just justification necessary. No justification necessary. Plus or minus.
Wait, I got my costume. Okay, I have it. Well, it's just the white stuff was good. I hadn't gone there since I got my school costume.
You're not even there.
Great. And I learned wanting out. They have some good.
Did you see any gifts?
Wait, ours completely opposite. You play it into
Oh, werewolf. They had a werewolf mask.
Yeah, so
No, I don't need that.
Oh wait, no, but I got
Oh, yeah, you like it. I know how to do it.
We'll see. We'll see.
So it's just opposite of what I do. I think it's number and then
What's this one?
8. Yeah, I did.
Negative.
I got the local max was 0.302 and the local min was 2.7.
I can tell you for a second. I thought it was cooked.
I'm saying I could really.
Number 10.
Oh. His room is the coolest one ever.
I actually started thinking maybe it'll feel my leg. Wait, but it's
Back to Jay. I think it's gonna be good look concept.
I did get to 10 and I skipped it.
X.
Because I don't want to do it.
5 to the x times 5. It's already e to the 5x
No,
times
just
5.
cause.
Times 5. Yeah, because there's yeah.
The 5 goes down.
Dude. Hey, y'all alright? Alright, take Lily. Hey, I can take Sam and Jake.
Yes sir, do that, bro. You can say yes, bro, because otherwise Sam's gonna be in the car. No, Jake's chilling with you, but like Sam would take her on my like conversation with her, bro.
Sam and Jake is right.
Yeah.
Because it's your car.
Yes sir. Who are you taking right now? Maddox and Jake.
Jake, Sam.
Yes. What about Henry? You can take Henry.
Just tell me. I'm not gonna tell you. You can have to tell
Well, I know sometimes Beth would come over to my desk.
I know.
She would take my instrument and it was just
I'm so sorry.
why are you apologizing? We're all in this together. It's painful, right? What if I started AP Cup is AP was really high school.
You know what? I think 6 did help with my
Can I be the
like now I can like
I don't know what.
Tying the natural law, especially when we did that.
I mean she is
That's at least the third time I've told you.
That's why
Plus 3 you get 5x. 5 means 5x. Okay. You're just gonna go. No, I think. What would just be? You already pushed it.
Well, I got negative.
Yeah.
I think it's negative. Well,
Now, of course, you should not do this as a way to get answers, but questions 9 through 14 give you a function. So you could graph the function in your calculator, see where there's max and mins, and see if that's matching up with your calculus or not. So don't just graph it, look at it, and give an answer based on that, because you're not going to get the practice that you need. But.
so you get this over.
It's 0 plus e plus c.
How does it take this out? I can figure that is actually the best.
E to the 5 is 5 is 0 plus 1. What did you Yeah, you plug it, when you plug it in. Yes, so this would be 0 plus.
Wait, how'd you get that?
So, yeah. We don't want that.
Because this is what my graph looks like. Did I even do it this far right? Is it wrong?
I hope I'm saying
Yeah, because you have 5 to 9.
The only thing that scares me here is when you take the square root of
I just don't know.
half your number plus or minus.
One of you just automatically.
I was actually thinking that in this class, right?
Oh, okay, that makes sense. Wait, you didn't even know
I said we could switch it up and go.
Did you know E equals
These are critical numbers. You don't have to.
Assume 0 and equals going down here.
It's a number. It's like it's like saying once I get 5
Oh, yeah.
This is the only thing
No, assume
it's
0
it's still
equals
something. But low key, I can have that squared so I can.
We'll get there.
It depends, like, if it was one, yeah, if it was 2,
I'll talk to my parents because I think my dad and my sister are going separate.
Wait, 0 to the 5 to 1.
What is the derivative
Is this like, I kind of just.
It's like e to 5x times not the log right of don't forget chain rule.
And then put 0 into it.
Oh, okay,
So, like,
okay.
0.
What's e to the 5x?
And so I just moved on.
Plug 0 into
It's
what?
not possible. Just plug it in
Okay,
then.
but this.
The function?
It's not possible. Plug it in.
Okay, well, first off, you shouldn't use a calculator on this. So to solve this, see how this has an e to the 5x and this has an e to the 5x? Right. So you got e to the 5x times.
You're on this one from there.
It goes down twice. It goes
So e
down.
to the 5x is always positive.
And then you wrap, and then you find it.
So it's just X.
Plus and minus.
It is not.
It's just minus.
No. Oh, right here, you forgot to change it.
Yeah.
Oh, because I need to
You need a
multiply
5.
by.
Yeah, it goes over 5.
So the only critical number is
So you
like
multiply
That would just be,
-1/5.
you know what that'd be?
Like 5.
1 over.
When you took the derivative of e to the 5x, it would be e to the 5x times.
What's 5 to the? Oh, it's not
So the
5.
critical number should be negative.
No, 5x. No, 5x.
Oh, like, cause I did 5 to the X. Giving bro. You got it.
I'm just assuming she's. I don't know, it's actually say 9. You're on to something.
Maybe that's it. Maybe that's the only thing, you know?
If we both want.
Do you think it was
Maybe that's all the role playing for each
I mean, I feel like it'll definitely be less busy on a Tuesday, just like one where I never tried it. Well, the only pizza my family eats.
Oh yeah, part of you.
Wait.
I mean, it is good.
Why do you have L?
Oh.
That's I. That's
Oh wait.
My mom used to work for
I was like, you're like.
Wait, oh,
No, I would know. That'd be great. The person with the last name, so she does.
It was so
My mom used to have social media.
Well, it was 2 degrees warmer than in
So
here.
we
It
got
just
fruit
felt
and
amazing.
got granola mushroom every day.
I it wasn't 9 years old. They had me working so late.
Cheating roll.
I was gonna work out already.
I was too.
So much fun, right? Yeah, it's just like mellow, especially during the school year, bro. Like 10 minutes to close. So many places in order to like.
Why do you have L?
It's that is on
Like that's literally like
natural law.
makes you want to be based on the flat top.
Because the derivative negative of e to the 5 if you're saying that
What's that? Oh, you're right. Exponential. Oh my god. I know. I'm aware.
it should be
You know what's going to make it faster is if you stay busy.
One box on paper that was done.
It's just easy to buy.
That's so sad. I actually get one. It's probably better than McDonald's.
I agree.
Really?
If you plug in a negative one, then she's choosing negative 1 plus 1.
She hates me. No, where?
If you plug in
I'm like, I'm just
Okay, so
I'm working on this.
how do you
now we have to.
So my question. It's 0.
Oh, because look, oh wait, I didn't do the. I did the red, not the blue.
Because
It's
yeah, 2 squared is negative 4.
and there's.
So what do we do if we plug in? Because if you plug in,
It is.
if I plug in.
Or you could plug it in over here.
Because I'm there. Because I'm there.
Negative
Well, I was doing like 0 to 0.
Plug in 0.
Positive. Positive times positive is positive.
Tell us how it goes now. It's gonna be 0.
The reason it's
0 is not a positive or a negative.
the reason it's not.
That's why I just did
He's the negative.
I negative.
Oh,
I don't think 0.
Minus 5 is negative 2.
Well, what's actually
Is it
Yeah.
5x or 5?
Wait, you know,
Oh,
it's
it's
like a number.
wait, it's 5x.
I know E is
Wait,
like
for
2
what?
point something.
It's 5.
2.78 something like that.
E to the negative 5x is the same as 1 over e to the positive 5x. So if you're plugging in 0.
What?
it's
What is
still gonna be
what is
1
so
over
funny?
I don't know.
Or if this
What?
is.
Oh, it's positive. It's still positive.
Let me say that question.
And then
You had to the 5x, and you're plugging in x is negative.
So it's positive.
So that's e to the negative 5,
So it become 1 over each of this.
which is still positive.
And then, but it's so, wait, then,
Well, that would be positive.
you should have seen that. Oh my God. Get a 0.
I'm fine, I'm just double check.
Wait, it's possible.
And then you make it negative. So then that one is
Oh, wait, no, I can't even read my handwriting. But I've got
Hit y equals, let me see what your y equals is. Probably that you got this that plus is on, and those are off. I would turn them all off personally. That's usually the mistake.
One of them should be negative.
Watch what negative 1 over 5, not the
So you just copy the word? Are you gonna make the break?
Mr. Townsend?
Wait,
This problem
So they got-
might have to like the solution.
See, I'm not going to play it, but if you happen
Yeah.
Probably
So x equals negative, this isn't that important. X equals negative 1 is considered a critical value because it makes the first derivative 0 or 1. It can't be a critical point because if you try to plug negative 1 into the function,
when Jackie would.
yeah, there's no point. So it can't be a critical point if the point doesn't even exist. That's what it is.
I bought it from the wild.
I plugged in the.
I'm just like.
What's x?
Wait, when did you buy it? Okay,
No, I got it in
Oh, yeah.
They have Urban Outfitters.
I would find this.
So you, on the top and on the bottom. When the numerator is 0. So you.
I need to do this first. But I got positive.
Oh, for the last 3?
Okay, negative 3 halves. And negative 1 has 2
Imagine being, imagine being a night school.
No, it's minus x. It's minus x.
Yeah, the entire same stuff.
X to the 4.
Yes, because it's x equals.
Wait, easy, I got negative for the first one. Well, again, well then, I guess it's more
And we all have the same thing. That's right.
Negative 2 is half. What's 1 over 2? Exactly.
Make that equal 0. And then you
Well, it's not 3 over.
you take x to the. So then it's just 2x plus 3 equals 0. X equals 2x 3.
At the end of the day, it's not that much time. Like in the grid. In the grid.
And then you also can do the denominator.
An hour, 30 minutes. 90 minutes.
Yeah, that's what I.
Oh,
You're only living,
You're only living when you're in the calculation.
What's going on?
Only you when you're in the
How
calculation. How much was it my work today?
We got
I got it
negative 1.
equal.
Yeah, we got negative.
we both know.
I'm gonna check now. I only got one.
What are your critical numbers on?
Where is this second one? Where is this?
11.
I like using
I
that.
got negative 1 and 0.
I got negative
How'd you
1,
get
0,
another?
negative 0.
Because I just got an extra.
I got the,
I got positive and negative 1.
wait, what positive and negative?
I don't know. I was-
No, you're right.
I got
Okay.
negative.
It's a good thing I checked your work there before you.
I did it wrong. I did it plus 2, so I did it plus 2.
Negative.
I did it wrong. Give me a minute to read
Recombine.
So this also goes.
myself.
So cold. Mr. Townsend, do you like control the thermostat in your room?
No, there's no.
I know there's no heat, but like,
Do I control it?
like do you like to keep your room cool?
You can positive if it's in that.
It's 63 degrees.
Positive 1.
Did you get this?
My thermostat does not work.
There's no. Okay, I'm going to.
I have x equals negative
No, that's a negative construction this week.
Why is it negative?
Because you need the 3 over. So you did. It's a negative.
I used to have a Stacy here.
So
Plug it in. One more value.
So, -1.
Back and forth 3 times.
So then in between -1, it's like you have the wire.
So I threw it away because I was trying to start a fire.
Are you plugging into the function or derivative?
So.
It's the derivative.
Now I have my line all backwards.
Plus 1.
Yeah, I see that. Right here.
That's where it would be. That'd be like
If you plug in negative 0, negative 3 halves, negative
In real life, I can erase your mistake. No, I made it up.
That's positive.
Don't get those wise.
So -2, negative. You're doing negative. You're doing negative.
That's not how we learn.
One person doing this.
Well, I don't care because I'm not
Yes,
doing
wow.
Wait, what?
The derivatives I'm doing.
Why are you doing negative? You don't need to do that.
I get a 5 on the exam. I can go become
Smaller.
Or
Or the positive, what I'm talking about.
It doesn't have to be between 0.
That's what I'm
I have
So.
Okay, look, these are the points, right?
Wait, where did you get -1 from?
This.
Okay, guys, we've got about 7 minutes left, so as always, you're encouraged to keep working on this. I do need you to finish up this worksheet as practice between now and Thursday, so you don't have to worry anything about that book assignment. We didn't get there, that's fine. But I need you to finish the worksheet and feel pretty good or pretty decent about what you're doing. So you don't have to be ready to take a test on it or anything, but you should feel pretty decent. If you'd rather do the daily puzzle, I think this is the one you're on. Is this the puzzle you're on?
Yes, I think so. We haven't done this.
Okay. So if you'd rather do that with your last 7 minutes.
I swear to God, you don't
Yes, you do.
You don't involve 0.
I felt no.
We need to involve 0.
You don't involve 0. Look.
I just got 5.
When we did this, we did this with him, we never said X was 0. We just like completely ignored it. Right there. That equals 0 because if you divide it. This, when you divide it 3, we never did that.
It's so positive.
Yeah, it's for
Y'all know the answer to the puzzle.
Wait.
If he goes 20 kilometers an hour, so we just ignore those.
Look, he took the denominator of this. That's right. What did I do here? I took the denominator and I made it into 0, and that's what I got.
Yeah, I'm asking about this. You don't need
And of course, please check your answers on it as well. Learning from some of your mistakes. Those are on the class website already.
Wait, Mr. Johnson, I have one.
All right.
Why wouldn't this also, so this is the,
Yeah, that's fine. She got it.
this is the thing.
Yeah, but that's a road. That's a
X squared, wouldn't you put X?
part of your derivative.
I messed it up, it's just,
That is amazing.
well, I'm not there. It was still there, I knew it was there.
Someone got my number from Lena.
No way to give
And
us
then,
numbers.
Say, hey, please.
and then, what is this, right? Okay. Wouldn't you put an X squared?
Wait, what did you
And then that would get you.
I don't respond to text because I don't know because I'm a good.
So wait, then why don't we do that when we did the
I'm a
notes?
responsible.
Like for this, when we did the notes, so that equals 0.
Oh! Ooh! You can set 3 equal to 0.
Are you receiving?
Because I didn't realize that until we were just talking with
No amount of studying would have gone on for your well, the thing is, I did it. Okay, well, you still got. Yeah.
Hi.
Just like me.
I just studied so hard, and I still did it. Okay, look over the night before, and I had an epiphany, and then I saw the test, and it's like. I was like, I'm kidding, and I was like happy, and then I felt out.
It's just as confusing. But this is like actual like applied.
Okay, Dylan Sanders.
It is a little bit negative.
Like Dylan Sanders. Yeah, for pre-calculus and
I
AP.
got that super easy because it was just all under the map. You know, it was just like all like.
What do you think you're doing?
What do I think he's doing?
Or no. What do you think? Like he had your class. You had him for a while, right? He's cool, dude. What do you think?
He's alright.
All right.
He was actually a much better calculus student than pre-calculus. He
Really?
struggled a bit with pre-cal.
Okay.
And his first year, he did
Uh-huh.
great in calculus. I don't know. He never
Huh.
struggled with calculus.
Interesting. You don't see the two to be any different?
I think calculus is way harder personally.
Sorry. I got you.
Even if you know what you're doing in calculus, it's hard to get everything right.
Yeah. No, I'm. What about Daxon?
What about it?
Is Daxon know too?
Does Dax have 100?
I don't know if anybody has 100.
In calc? Or calc A, calc BC?
Speaking of which, you know he's trying to get girls' numbers on the weekend?
What? Okay, I've heard that.
Wait, what's
I've
that?
heard
What's
that
happening?
he's
Who, Daxon?
been being crazy. Everett and Camden, where they're the ones talking about it.
You can't get him a girlfriend?
Oh, he doesn't want one. He could get one. He just doesn't want one.
Daxon doesn't want it.
Yeah.
I don't know.
I have a question.
I can run the
This just only one person at X school spots.
He did not.
I don't know if I did that. It's like you
Oh, I have a 99.52.
Yeah, that's right. I don't know. I didn't test these, but yeah.